The Convair F-102 Delta Dagger emerged during the Cold War, a period marked by rapid advancements in jet technology and aerodynamics after World War II. This era saw the development of increasingly powerful and streamlined aircraft, making it one of the most exciting times in military aviation. A key concern for Western Europe and the United States was the threat posed by Soviet long-range, nuclear-capable bombers, leading to the creation of interceptors. These aircraft were designed for high-speed engagements, using advanced fire control systems, FCS, to target enemies at a distance with missiles. Initially serving as a deterrent, the F-102 later adapted for limited ground attack roles during the Vietnam War. Despite being operated by only a few nations, the F-102 had a service life of just over 2 decades before its retirement. Though similar in appearance to the later F-106 Delta Dart, the F-102 was more of a transitional interceptor until the F-106 met the original design objectives. In August 1945, as the United States Army Air Force began winding down its World War II operations, there was growing interest in jet-powered aircraft. This led to a requirement for an interceptor with supersonic capabilities. Jet propulsion was still in its early stages during the war, but key technological barriers had been overcome, highlighted by the German Messerschmitt Me-262, the first operational jet fighter. The U.S. Air Force specifications called for a maximum speed of 700 miles per hour and a service ceiling of 50,000 feet to counter Soviet bombers. Convair looked to German engineer Alexander Lippish's work on the Delta Wing design for high-speed flight. Convair, formed in 1943 from the merger of Consolidated Aircraft and Vultee Aircraft, hence the name Convair, was later acquired by General Dynamics and eventually faded from aviation history. Convair embarked on developing their own Delta Wing design for the U.S. Air Force, designated as the XF-92A. This concept featured highly swept leading wing edges and straight trailing edges, eliminating the horizontal tailplanes typical in traditional aircraft. The experimental airframe first took flight on April 1, 1948. It was powered by a single Allison J-33A29 turbojet engine, producing 7,500 pounds of thrust, allowing for speeds of 718 miles per hour and a service ceiling of 50,750 feet. The fuselage, though streamlined, had a stocky appearance with a triangular vertical tail fin and matching triangular main wings located behind the framed cockpit. Air intake was provided through an open nose. Despite its innovative design, pilots disliked the aircraft due to its violent flight tendencies and underwhelming performance. Ultimately, the USAF concluded the research with the project's formal cancellation. In October 1948, the USAF issued new requirements for an interceptor centered around the cutting-edge MX-1179 Electronic Fire Control System, FCS, designed to manage advanced radar and missile systems. The aircraft needed to achieve Mach 2 speeds and be production-ready by 1954, aiming to equip the USAF with a formidable interceptor to counter Soviet bombers. The project progressed on 2 fronts. Hughes was tasked with developing the FCS, while Convair secured the contract to build the airframe. Drawing on experience from the XF-92 program, Convair introduced the XF-102 prototype, which shared a similar design. The XF-102 bore a strong resemblance to the earlier XF-92, but featured a significantly longer fuselage and larger delta wings. Like its predecessor, all wing surfaces were triangular with pointed tips and swept leading edges. A single engine was housed within the tubular fuselage, while the cockpit was positioned far forward. Though initially intended to use the Wright J67 engine based on the British Bristol Siddeley Olympus, delays led to the temporary choice of the Westinghouse J40 engine. When the J40 project failed, the Pratt & Whitney J57 engine was selected instead. The development of the Advanced MX-1179 Fire Control System (FCS) was also behind schedule, necessitating the installation of the simpler MG3 FCS in the meantime. As such, the XF-102 served as a stepping stone, ironing out technical challenges while the key components continued development. The XF-102 was expected to evolve into the F-102A production interceptor, while the later F-102B model would incorporate the planned FCS and engine. This approach allowed the USAF to field a capable interceptor while waiting for the program's full objectives to be realized, ultimately leading to a more streamlined final product. Like other USAF programs, the XF-102 prototype advanced to the evolution stage as the YF-102. Its first flight took place on October 24, 1953, though the prototype was lost less than 2 weeks later. A second prototype was ready by January of the following year, but showed disappointing performance, unable to break the sound barrier and achieving only subsonic flight. To address these issues, Convair engineers adopted the German wartime-inspired Whitcomb area rule, a design technique that reduced drag in fixed-wing airframes when approaching and exceeding Mach 1. The YF-102 was extensively redesigned, with the fuselage lengthened by 4 feet and pinched at its midpoint. Additionally, a more powerful Pratt & Whitney J57P23 turbojet engine producing 16,000 pounds of thrust was installed and fed by larger, improved air intakes. The wings were further refined, and in this modified state, the YF-102 evolved into the YF-102A. The YF-102A first flew on December 20, 1954, successfully achieving the required supersonic speeds and service ceiling, proving the redesign a success. With the aircraft refined to satisfactory standards, the USAF ordered it into serial production under the name F-102 Delta Dagger. The initial production version, designated F-102A, saw a total of 889 units manufactured by Convair. The F-102's arrival marked the world's first operational production delta-wing supersonic aircraft. Production continued until September 1958. Outwardly, the F-102 projected a sense of speed with its sharp, clean lines and focused design. The fuselage was long and slender, with the cockpit positioned behind a nose cone assembly. Air intakes positioned on either side of the cockpit fed a single engine located at the rear of the fuselage, which ended with an exhaust ring. The delta wing configuration, set on either side of the rounded fuselage, featured highly swept leading edges and straight trailing edges that met at outboard points. A large vertical tail fin resembling a third triangular surface with a clipped tip capped the fuselage spine. The cockpit, a two-piece installation with framing, provided good forward, side, and upward visibility, although rearward vision was limited by the raised fuselage spine and side intake bulges. As an interceptor rather than a true fighter, extensive cockpit visibility was not a primary design concern. The undercarriage followed a conventional tricycle arrangement with fully retractable gear, 2 main landing gear legs under the wings, and a single nose wheel leg under the cockpit floor. The initial production models were equipped with the Hughes MG3 FCS, while later versions featured the more advanced Hughes MG10 FCS. The F-102 was powered by a single Pratt & Whitney J57P23 turbojet engine, producing 11,700 pounds of thrust. With the afterburner engaged, which involved injecting raw fuel into the engine for temporary speed boosts, At the cost of reduced range, the thrust could increase to 17,200 pounds. This provided the aircraft with a top speed of 825 miles per hour and a service ceiling approaching 54,000 feet, exceeding the original USAF interceptor requirements, though not reaching the Mach 2 speeds initially envisioned. The F-102 had a range of up to 1,350 miles and a rate of climb of around 17,400 feet per minute. As an interceptor, it was designed to quickly ascend to altitude, travel to the interception point at high speed, and deliver ordnance accurately at range. Interestingly, for its time, the F-102 featured weaponry housed in 3 internal bays located under the main fuselage. This decision choice reduced exterior airflow and helped maximize speed, while also somewhat lowering the aircraft's radar signature. As an interceptor, the F-102 was equipped with air-to-air missiles designed to target Soviet bombers. It could carry up to 6 missiles, including a mix of semi-active radar homing AIM-4A Falcon and infrared homing AIM-4C Falcon types to address different interception scenarios. Additionally, provisions were made for 24 folding fin aerial rockets, FFARs, in the 2 forwardmost weapon bays, useful for short-range engagements. Weapons management was handled through an additional control column in the cockpit, with the fire control system capable of automatically directing the aircraft to its target. Later in its service, the F-102 was adapted to carry the AIM-26A nuclear Falcon missile, enhancing its deterrent capability against the Soviets. Reflecting the shift in military aviation towards missile technology, the F-102 did not feature an onboard cannon. To extend its operational range, the aircraft commonly utilized drop tanks, one mounted under each wing. As the Delta Wing fighter was a new addition to the U.S. Air Force, Convair developed a 2-seat trainer variant of the F-102, designated the TF-102A. This trainer retained combat capabilities but had reduced performance due to a revised, bulged front fuselage necessary for side-by-side seating of a student and instructor. A total of 111 TF-102As were produced and extensively used for training all F-102 operators. The F-102 was finally delivered to the U.S. Air Force in April 1956, 2 years later than the planned operational date. New pilots were trained using the TF-102A trainer models. The F-102s served with the U.S. Air Force Air Defense Command until 1960, focusing on defending the continental United States from Soviet air threats. The aircraft were not used in combat until American involvement in the Vietnam War, where every available aircraft was pressed into service to support South Vietnam against communist forces. The F-102s arrived in Vietnam in 1962, initially used for their speed as interceptors and repainted in the Southeast Asia camouflage pattern. Later, they were used as fighter escorts for the Boeing B-52 Stratofortress bombers. As the conflict evolved, the F-102s and the TF-102 trainers were adapted for ground attack roles, carrying high-explosive rocket ordnance. The F-102 remained in the Vietnam theater until 1968, with only 1 loss to enemy air-to-air combat and a total of 15 F-102s lost during the war. As the F-102's peak years passed, many of the airframes were converted into piloted and pilotless target drones for weapons training. Initial conversions began in 1973, with a total of 217 aircraft modified under the designations QF-102A and later PQM-102A through B. The last F-102 drone was destroyed in 1986, providing valuable live-fire training for USAF pilots. There was also a lesser-known proposed strike variant of the F-102, designated the F-102C if produced. This variant was to be equipped with the J-57P-47 engine, an internal gun for close-range combat, and a pair of hardpoints under the wings for conventional drop ordnance. An internal refueling probe and larger internal fuel stores would have extended its operational range. 2 YF-102C prototypes were developed, but the variant was never implemented. The F-102 saw limited overseas deployment, with units delivered to U.S. allies in Turkey and Greece. Turkey received 50 F-102A aircraft and trainers starting in 1968, using former U.S. Air Force models until their service ended in 1979. Greece took delivery of 24 F-102A aircraft and trainers in 1969 and operated them until 1978. The U.S. Air Force officially retired the F-102 from interceptor service in 1976. It served with various commands, including Air Defense Command, Alaskan Air Command, the United States Air Forces in Europe, the Pacific Air Forces, and the Air National Guard. At its peak, the F-102 equipped over 70 interceptor squadrons, with 26 active under Air Defense Command. The rise of more versatile, multi-role aircraft and advanced ground-launched intercept missiles contributed to the decline of the interceptor as a key component of modern warfare. On December 15, 1959, Major Joe Rogers of the United States Air Force Flight Test Center set a world absolute speed record while piloting an F-106A with the serial number 56-0467. Flying along an 11-mile, 18-kilometer straight trajectory at an altitude of 40,000 feet, 12,192 meters, he achieved a speed of 1,525.95 miles per hour, 2,455.77 kilometers per hour, or Mach 2.39. This surpassed the previous record of 1,484.3 miles per hour, 2,388.95 kilometers per hour, set on October 7, 1959 by Colonel Georgy Moselov of the USSR in a modified Mikoyan YE-63 known as YE-66, a MiG-21 F-13 with an alternative engine, by 34.63 miles per hour or 55.73 kilometers per hour. The Convair F-106 Delta Dart, manufactured by the Convair Division of General Dynamics, served as a supersonic, all-weather delta wing interceptor aircraft for the United States Air Force from the 1960s until 1988. Developed as a dedicated interceptor, the F-106 earned the title Ultimate Interceptor, designed specifically to intercept and neutralize enemy aircraft, particularly bombers, using the Hughes MA-1 electronic guidance and fire control system. The F-106 Delta Dart remains the last dedicated interceptor in the U.S. Air Force's inventory. Initially conceived as an advanced version of the F-102A Delta Dagger and designated F-102B, the aircraft underwent significant modifications that led to a redesignation as the F-106 in June 1956. Exclusively designed as an interceptor, the F-106 was powered by the Pratt & Whitney J75-17 engine. The single-seat F-106A made its first flight on December 26, 1956, and was delivered to the U.S. Air Force in May 1959. It began its operational service with the Air Defense Command's 539th Fighter Interceptor Squadron at McGuire Air Force Base in New Jersey. The F-106A achieved full operational capability in November 1959 with the 498th Fighter Interceptor Squadron at Geiger Air Force Base, Washington. The two-seat F-106B, which retained the F-106A's combat capabilities, first flew on April 9, 1958, and reached initial operational status by July 1960. Production of the F-106 ended in late 1960 with a total of 277 F-106As and 63 F-106Bs built, each costing approximately $5 million. The F-106 Delta Dart served as the primary alert interceptor for the Air Defense Command, tasked with defending against potential Soviet nuclear bomber incursions throughout the 1960s, 1970s, and into the 1980s, until it was replaced by the F-15 Eagle. The last active-duty F-106 was stationed with the 49th Fighter Interceptor Squadron at Griffith Air Force Base, Rome, New York, and was moved to Embark at Davis-Monthan Air Force Base in Arizona for storage in 1987. The final squadron to operate the F-106 was the 119th Fighter Interceptor Squadron of the 177th Fighter Interceptor Group in Atlantic City, New Jersey Air National Guard, which continued to fly the aircraft until June 1988. The development of the F-106, along with its predecessor, the F-102A, is closely linked to Langley and the development of area ruling in the early 1950s. Area rule is a design technique aimed at reducing drag at transonic speeds, evident in the Coke bottle or wasp waist fuselage shape of the F-106. This technique allowed the YF-102A to surpass the speed of sound, setting the stage for the more advanced F-106. Richard T. Whitcomb, the innovator behind area ruling, received the prestigious Collier Trophy from the National Aeronautic Association in 1955 for his groundbreaking work, which was recognized as the most significant achievement in aeronautics that year. The F-106 Delta Dart was powered by a single Pratt & Whitney J75 P17 turbojet engine, producing 16,100 pounds of thrust and 24,500 pounds with afterburner. The first F-106A, serial number 56-0451, was completed by the end of 1956. Its maiden flight, conducted by Convair test pilot Richard L. Johnson at Edwards Air Force Base on December 26, 1956, encountered several problems. The flight had to be cut short due to fluctuations in the air turbine motor frequency and malfunctioning speed brakes, preventing the aircraft from reaching supersonic speeds. The second aircraft, serial number 560452, took its first flight on February 26, 1957. Both aircraft were equipped with the YJ75P1 engine. The initial F-102B, F-106, YF-106A, with serial number 56-0451, was transported from Convair's facility in San Diego to AFFTC Edwards Air Force Base, California, on December 14, 1956, and began taxi tests on December 22, 1956. Its maiden flight on December 26, 1956, was limited to a 20-minute duration, reaching altitudes of 30,000 feet and speeds of 0.8 Mach without afterburner. This performance was comparable to that of an F-102 Delta Dagger taking off with afterburner. The F-106B, serial number 57-2507, built by Convair, completed its taxi test at AFFTC Edwards Air Force Base, California on April 8, 1958. Its inaugural flight took place on April 10, 1958, with Fitzpatrick at the controls. This flight was notable for lasting 50 minutes, nearly twice as long as the F-106A's initial flight, and it reached higher altitudes and faster supersonic speeds than typical for a maiden flight. This performance was likely due to the proven reliability of the F-106A, as the F-106B was very similar in design. On December 15, 1958, Major Joseph W. Rogers set a world speed record in a Delta Dart, reaching 1,525.96 miles per hour, or 2,455.79 kilometers per hour, at an altitude of 40,500 feet, or 12,300 meters. Later that year, Charles E. Myers piloted an identical model and achieved a speed of 1,544 miles per hour, or 2,484 kilometers per hour. The F-106A, with serial number 56-0459, was initially chosen for the record attempt and is often cited in historical accounts as the aircraft that set the record. However, this aircraft faced engine compressor stall issues, severe yaw oscillations, and problems with the variable engine air intake controls just hours before the record attempt, which led to its grounding. The standby aircraft, serial number 56-0467, had not undergone any specialized preparations except for modifications to the limit screws on both the engine and afterburner fuel controls to allow over-limit operation by the pilot. Major Rogers flew this backup aircraft, setting a new speed record. He reported reaching Mach 2.43 and was still accelerating at the end of the course. This record stood until November 22, 1961, when it was surpassed by a McDonnell F-4H-1F Phantom with Lieutenant Colonel R.B. Robertson, a fellow member of the United States Air Force Flight Test Center, achieving a new world speed record. Although the F-106 is still recognized for holding the world speed record for single-engine aircraft, there have been Soviet claims that they surpassed this record on July 7, 1962. According to these claims, Colonel Georgy Mosilov of the USSR flew a single-engine Mikoyan Gurevich YE-166, a variant of the YE-152, designated specifically for this attempt, and reached a speed of 1,665.98 miles per hour, or 2,680.92 kilometers per hour. However, this claim has never been verified. Early operations of the F-106 were plagued by technical issues, including generator defects, fuel flow problems, particularly in cold weather, and combustor starter malfunctions. In December 1959, all F-106s were temporarily grounded following an incident where the canopy was accidentally jettisoned mid-flight on one of the aircraft. The F-106 Delta Dart did indeed benefit from extensive modifications and retrofits by early 1961, which addressed many of the initial issues and improved its performance and reliability. The aircraft's unique design and capabilities made it a favorite among pilots despite the early challenges. The F-106 was deployed in various strategic locations, including the contiguous United States, Alaska, and Iceland, reflecting its role in defending against potential Soviet threats. Its brief deployments in Germany and South Korea also highlight its versatility and the broader scope of its operational reach. Indeed, the F-106 Delta Dart was the second highest numbered PF aircraft under the old numbering system, just behind the F-111. This high numbering reflected its advanced status and significant role in the interceptor category. The nickname The Six became more commonly used than Delta Dart, partly due to its ease of reference and the aircraft's association with the number 6 in its designation. The introduction of the F-106 led to the retirement of older interceptors like the F-86 Sabre and the F-89 Scorpion, making a transition to more advanced interceptors. The F-106 did not see combat in Vietnam, and no foreign sales were made, which kept it within U.S. forces. The aircraft's operational history remains notable for its role in air defense and its advanced design features for its time. Operation High Speed was a pivotal evaluation that showcased the strengths and weaknesses of the F-106A and the F-4B Phantom. The F-4 Phantom's capability to carry a substantial bomb load and a variety of missiles, along with its advanced avionics and multi-role versatility, gave it a clear edge over the F-106A, which was designed primarily as a dedicated interceptor. In the late 1960s, the F-4 Phantom began to serve as an escort and eventually took over from the F-105 Thunder Chief. Its broader operational capabilities made it an invaluable asset for both air-to-air and air-to-ground missions. Throughout its service, the F-106 Delta Dart underwent continuous upgrades to maintain its effectiveness as a premier interceptor. These included significant improvements in avionics to keep pace with evolving threats, as well as modifications to the wing to include a conical camber, which enhanced performance in handling its supersonic speeds. The integration of an infrared search and track system further improved its target acquisition and tracking capabilities in all weather conditions. Additionally, the introduction of streamlined supersonic wing tanks extended the aircraft's range without greatly affecting its performance. These enhancements ensured that the F-106 remained a formidable interceptor throughout its service, even as newer aircraft like the F-4 Phantom began to assume its role. The F-106 Delta Dart was equipped with advanced instrumentation, including an in-flight refueling receptacle for extended range and an arrestor hook for emergency landings. In air-to-air combat assessments, the F-106 demonstrated competitive capabilities against the F-4 Phantom II, particularly in dogfights. Its superior high-altitude turning performance and overall agility were attributed to its lower wing loading, allowing it to outmaneuver the Phantom in certain situations. The F-4 Phantom II had several advantages over the F-106 Delta Dart. It was equipped with advanced radar, operated by an additional crew member, and could carry up to 4 radar-guided AIM-7 Sparrow missiles and 4 infrared AIM-9 Sidewinder missiles. In contrast, the AIM-4 Vulcan missiles used by the F-106 were less effective in dogfighting scenarios, particularly during the Vietnam War. The Phantom also had a higher thrust-to-weight ratio, superior climbing capabilities, and better high-speed and low-altitude maneuverability. Additionally, it can be employed as a fighter-bomber, a versatile role that the F-106 could not match. The combat experiences in Vietnam highlighted the need for improved pilot visibility and the effectiveness of an integrated gun, features that were added to the E variant of the USAF Phantoms. To address some of these shortcomings, Project 6-Shooter in 1972 saw several F-106As upgraded with a new canopy that eliminated metal bracing, thereby significantly enhancing pilot visibility. In addition to these upgrades, the F-106 Delta Dart was fitted with an optical gun sight and provisions for an M61 Vulcan 20mm cannon. This cannon, housed in the central weapons bay and supplied with 650 rounds of ammunition, replaced the AIM-26 Super Falcon or Genie missile. The transition to the F-15 Eagle began in 1981, leading to the allocation of most F-106s to Air National Guard units. The F-106 continued to serve in various U.S. Air Force and Air National Guard units until 1988. Between June 1, 1983 and August 1, 1988, the Delta Darts were gradually retired and moved to the Military Storage and Disposition Center in Arizona. When there was a need for high-performance, full-scale aerial target drones, the USAF began withdrawing these aircraft from storage. Starting in 1986, 194 surplus F-106s were converted into target drones and designated QF-106As. Under the Pacer 6 program, the F-106 Delta Darts were repurposed as target drones by the Aerial Target Squadron. These drones retained the capability to be flown as manned aircraft for ferrying to test sites, but were operated unmanned during tests. The final QF-106 was destroyed in January 1998. The QF-106 drones replaced the QF-100 Super Sabre drones. The last QF-106, serial number 57-2524, was shot down at Holloman Air Force Base on February 20, 1997, and was subsequently replaced by the QF-4S and QF-4E Phantom II drones. On February 2, 1970, during a routine training flight involving aerial combat maneuvers, an F-106 Delta Dart went into a flat spin. First Lieutenant Gary Faust, the pilot, made multiple attempts to regain control, including deploying the aircraft's drag chute as a last resort. Despite his efforts, he was unable to recover the aircraft and was compelled to eject at an altitude of 15,000 feet or 4,600 meters. The ejection of the pilot led to a reduction in the aircraft's weight and a shift in its center of gravity. Additionally, the propulsive force from the ejection seat pushed the aircraft's nose downward. These factors combined to help the aircraft, which had been trimmed for takeoff and was at idle throttle, recover from the spin. Faust landed in the nearby mountains and was rescued by locals on snowmobiles. The local sheriff and residents approached the crash site where the still idling jet engine was causing the plane to drift slowly across the field. A recovery crew from McClellan Air Force Base was then dispatched to dismantle the minimally damaged aircraft for transportation. It is said that an officer from the recovery crew commented that, had the aircraft been even less damaged, he would have flown it out of the field himself. After its unintended landing, the aircraft, nicknamed the Cornfield Bomber, was restored and returned to service with the 49th Fighter Interceptor Squadron, the last Air Force unit to deploy the F-106. In 1979, Faust had the opportunity to pilot the aircraft again during training at Tyndall Air Force Base. The aircraft was eventually retired and donated to the National Museum of the United States Air Force in August 1986, where it continues to be showcased.